In this video, we're going to learn how to graph polar equations, but those equations are going to be roses. Roses are going to be identified by this form of equation. Okay, let's move to the next page and see how can we identify a graph that is going to be a rose in a polar equation. Okay, so if we have something like r, it's equal to a constant a times sine of a number times theta times an angle, then we're going to have a rose. Okay, if we have something like r, it's equal to a cosine of n theta, we are also going to get a rose. Okay, this n right here is going to give us the number of leaves on that rose. So this will be the number of petals on the rose. Okay, and this a is going to lead to tell us how long is going to be the rose, how long. All right, this information is going to be really useful for how many petals we're going to have. So if the number of petals it's odd, right, odd, then the number of leaves, the number of petals is going to be equal to that same n. Okay, if it's odd, it's going to be equal to n, all right, to the same value. So if we have 3 theta, since 3 it's odd, then we're going to have 3 petals. Okay, if it's even, so if it's even, the number of petals is going to be equal to 2 times n. All right, so if it's even, so maybe if this is 2 and it's going to be equal to 2, then the number of petals must be 4 because 2 times 2 is 4. Okay, that is how we're going to use the information on the equation to graph the rows. We're going to grab more information out of this. So let's try to do an example. All right, so let's try to grab this equation. It says r is equal to 2 times sine of 3 theta. But we know that this is going to give us information on how far, this is how far it's going to stretch out each leaf. This tree is going to give us information about the number of leaves. Since it's odd, then we know that we're going to have the number of petals is going to be equal to 3. We know we're going to have 3 petals. And for sine, the number of the petals, the first petal is always going to be in the first quadrant. For cosine, the first petal is always going to be on the horizontal axis. Okay, so remember that. For sine is going to be in this quadrant. Okay, so to know where the first leaf is going to start, what we're going to do is take 90 degrees, since this first quadrant represents 90 degrees, and we're going to divide it by the number of leaves. So since we have 3, then 90 divided by 3 is going to be 30 degrees. Okay, let me write this tree properly, 30 degrees. So if you notice on our polar grid, and this time in this video, we're going to use a polar grid because it's going to be a little bit easier to spot the degrees and how to add them and whatnot. 30 degrees is probably going to be right here. 30 degrees. Why is that? Notice that we have some thick lines. This thick line, it's dividing each quadrant into 2. So this is 45 degrees. Right? If this is 45 degrees, then this is going to be 30. This is going to be 15 degrees. 15 degrees. This is going to be 45 degrees. It's going to be 60 degrees, 75 degrees, 90 degrees, and so on and so forth. So let's use this. Let's use this. So we know that this is going to be 30 degrees. Let's mark it with this color, 30 degrees. Okay, so we know that our first leaf is going to be here. A is telling us that our leaf is going to graph 2 circles, right? It's going to reach 2 circles. So it's going to be 1 and 2 right here. Since it's a little bit small, we can do a little change and says that our first circle, we're going to change the scale. So our first circle is going to be here. So I'm going to take 2 circles and it's going to represent 1. So another 2 will be 2, another 2 will be 3, and so on and so forth. I'm doing this so we can see how long it's going to stretch out better. So I'm going to take 1 circle and 2 circles, right? So because a is equal to 2, I'm going to grab it 1 and 2. Remember that we changed our scale, all right? Now we know that the rose is going to have 3 leaves. So we need to share the leaves evenly on this whole grid. So we know the whole grid is 360. So if we have 360 and we're going to divide it by 3, this is going to give us 120 degrees. So we know they're going to be 120 degrees apart one from the other. So if I start on 30 degrees plus 120, we have 150 degrees, right? We have 150 degrees. So this is 90, right? 90, 30 more is 120, 30 more is going to be 150. So this is 150. All right, let me write it here. So this is 150. Okay. So we know that we're going to take 2 circles, right? So for this line, that is 150. I'm going to take 1 and 2. Remember that we change our scale. 2 circles actually means 1. Okay. And since our next leaf is going to be 120 apart of this one, so 150 plus 120 is going to give us 270 degrees, right? So we know that 170 degrees is going to be right here on this line. So 1 circle, 2 circles, okay? And we're going to graph our leaves. Our leaves is going to be something like this, all right? Whoops, that one. It's going to be something like that, right? That one, that being a little bit chubby. All right, so that is our rows for this equation, all right? So this equation can be represented with this graph. This is the graph approximately, right? This is the sketch. If we want to be precise, then we need to plot points and be precise on the graph. Okay, let's try to graph another example with odd n number. So maybe we have to graph r, it's equal to 3 sine of 5 theta. Okay, maybe we need to graph that. We know that a is going to be equal to 3, right? So we know that we are going to take 3 circles, or leaves or petals are going to be 3 circles of length. And this 5 is telling us the number of leaves. Since it's odd, then the number of petals is going to be equal to 5. Right? So remember that since we are dealing with sine is going to start in this quadrant. So we're going to take 90 degrees and divide it by the number of leaves. 90 degrees divided by 5, it goes 1 time. This is 4, 0, goes 8 times. So this is 0, so 18 degrees, all right? So we know that our first rows is going to start at 18 degrees. We know that this is 15 degrees, right? So 18 degrees should be something around here, okay? Something around that position, all right? Okay, we can even try to draw a line, all right, like that. All right, this is 18 degrees. All right, so we know that we need to space out 5 leaves. So we're going to take 360 degrees. We're going to divide it by 5. So 360 divided by 5 is going to be 7. 7 times 5 is 35. This is 1, so 2. So it's going to be 72 degrees, right? They're going to be spaced out by 72 degrees. So this is 72 degrees, right? If you add 72 degrees to 18 degrees, you're going to get 90 degrees. So our next leaves is going to be at 90 degrees, okay? So if we add to 90 degrees, we add 72 degrees, we're going to get 162 degrees. So remember that if we, let's see where it take us. Remember that in our last example, 150 was right here. 150 was right here. So 165 will be here, right? Because each of these spaces is 15 degrees. So 165 is here. So that means that our angle will be a little bit further back. All right, let's leave it like that. So this will be 162 degrees. Let me put it with a different color. Same thing here. So 162 degrees, 90 degrees. Okay, so if we add to 162 degrees, we add 72 more. We're going to get 4, 13, and 1, 234. Again, this is 180, right? If we add 30 more, it's going to be 210. If we add 30 more, we're going to have 240. So we're going to go a little bit back, and around here, we're going to get our line. Let me do it a little bit better. All right, like that. All right, like so. This is going to be approximately 234 degrees. If we add to 234, we add 72, then we get 6, 10, and 1, 306, right? This is 270. We know that this is 270. If we add 30 more, this is 300. This is 300, right? But we're going for 306, so it's going to be a little bit more, maybe like that. All right, so this is going to be 306 degrees, right? So now we just need to graph our petals, right? Our petals are going to be 3 in length. So let's do the same as in the previous example. We're going to take 2 circles as 1. We're going to change the scale. So 1, 2, 3. So this means we're going to take 6 circles to get 3 in our new scale. So this is 1, 2, 3. This is 1, 2, 3. This is 1, 2, 3. 1, 2, 3. Remember that we changed their scale. 1, 2, 3. So we can see the leaves better. So our graph will be something like this. All right. Well, this one's getting a little bit funky. Like that. Like that. And like that. So this is our rows of 5 petals. Let's do some problems with a pair number of leaves. Okay, so let's grab another one. In this case, we're going to graph r is equal to 2 sine of 2 theta. Right, so this is a, and this is n. And since n is even, then we know that the number of petals is going to be equal to 2 times n. 2 times n will be 4. So 2 times n will be 4. We're going to have 4 leaves. Okay. So since again, we're dealing with sine, we know that sine is going to be in between these 2 lines, right? It's going to start the first leaf is going to be located in between these 2 lines. We know that we're going to have 4 petals in the whole grid. So we need to divide 90 degrees by 2, by that 2, to know where it's going to start, the first petal. I mean, so 90 divided by 2, this one is easy, 45 degrees, and this is 45 degrees, so we know that we're going to start right here, right? And since we're splitting, right, those 4 petals into the whole grid, we're going to divide by 4. So 360 divided by 4, it's going to be 90 degrees, right? So we know that it's going to be 90 degrees apart from this first petal, right? So this is 45 degrees. If to 45 degrees we add 90, we get 5 and 135 degrees, right? So it's going to be right here, 135 degrees. Remember that each of this line means 45. So 45, 90, 90 plus 45 is going to be 135 degrees. All right, if to that 135 we add another 90, right? We add another 90, we're going to get 5, 12, one more, 225 degrees. And we know that this is 180 plus 45, this is 225 degrees, right? To this same thing, we're going to add 90 more. You probably know by now that you don't need to keep adding since it's going to be the same. Since you know that these lines are dividing each quadrant evenly. So let's do it anyway. So this is 5, 11, you carry 1, 315 degrees. Again, this is 270 plus 45. is 315 degrees. Let's change our scale again so we can see the rows better. So this is 1, this is 2. So every 2 circles is going to be 1. This is our scale. So we're going to take 2 circles to graph this whole equation. So this is our first circle, second circle, 1, 2, 1 and 2, and 1 and 2. Remember again that we change our scale. So our graph should be something like this. All right, our graph should be something like that. All right, this is our 4-leaf or 4-petal rows. All right, so let's graph 4 sine of 4 theta. Okay, again, this is A. This is going to be N, and since it's even, the number of petals or leaves are going to be equal to 2 times N, that is 4, that is equal to 8. So we're going to have 8 petals, right? So to know, since we're dealing with time, we know that it's going to be here, right, in the first quadrant of our polar grid. So we're going to take 90 degrees and we're going to divide it by N, right, to know where our first petal is going to start. So 90 divided by N is 22.5 degrees. So our first petal is going to be at 22.5 degrees. We know that this is 30. We know that this is 15. So it's going to be something in the middle, right? Somewhere in the middle of this too. So it's going to be right here. All right. So this is 22.5 degrees, right? So how are we going to know how far they're going to be from one another? So if you take 360 degrees, we're going to spread the leaves evenly. So we know we have 8. So we're going to divide by 8. 360 divided by 8 will be 45 degrees. So if you add 45 degrees to that 22.5, you know where the other one is going to start. So this is 5, 7, this is 6, 67.5. Again, this is 30, 60 is going to be right in the middle. So, oops, it's going to be right there or around that position, right? So 67.5 degrees. Since we know that this, it's splitting everything evenly, we know that it's going to be located down here. I'm going to use this, and we know that it's going to be located down here, this one, right? So we know that we are going to have 2 leaves down here too. All right, we know now that we need to keep adding 45s. So 45 degrees is going to be 5 point, this is 12, you carry 1, 10 and 11, right? So it's going to be at 112.5 degrees. Okay, this is 90. If you add 30, then this is 120, right? And if you add 15 from 90, it's going to be 105. So you know that it's going to be right in the middle of this, right? It's going to be right in the middle of this. Right, this one's not that precise, so let's do it precisely, or try to do it precisely. So it's going to be like that. And we know that we're going to find another one in a second down here, right? So it's going to be symmetrical. So this, it's 112.5 degrees. If you add 45 more, so let me erase this to have a little bit more space. So we have 112.5 degrees, and we add 45 more. Then we have 5. This is 7. This is 5. This is 1. So at 157.5, we're going to have another one. Okay. So this is 90 plus 30 more. This is 120 plus 30 more. This is 150. So we know that it's going to be right here in the middle. So right here in the middle. It's not that in the middle. Let's try to do it better. A little bit in the middle. We know it's going to be symmetrical. So we're going to have another one here. All right. So we know that this is 157.5 degrees. So let's find the numbers for the others. If we add 45, we get 5, 12, 1 more will be 10, and 1, 200, and 202.5 degrees, right? And we can keep adding. So 202.5 degrees plus 45, right? Remember that we have a 0, so 5, 7, 4, and 2. So this will be 247.5 degrees. If we add another 45, then we'll have 5.1219, 292.5 degrees. And if we add 45 more, so 292.5 plus 45, it's going to be 5, 7, 13, and 1, 337.5 degrees. Okay, so I guess you can check all those numbers in your calculator if you want, but they're right. So we know that we're taking 4 circles, so we don't need to change I guess that we don't need to change the scale here. So we can take 1, 2, 3, and 4 circles. So here's the same: 1, 2, 3, 4 circles. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And we can graph our rows. So it's going to be something like this, right? It's going to be something like that. That one is a little bit chubby. Something. All right, so that is our 8 leaves rows for this sine equations. Right, so to graph cosine, only one thing changes, and let's try it out. Let's try it out. Let's try one with a pair number of leaves, and let's try another one with even. All right, so let's suppose that we need to graph 3 cosine of 2 theta. All right, so the main difference with sine is that cosine is always going to start on the horizontal axis and right here on this side. Okay, always going to start there. Since we have a 3 for A, then we know that it's going to stretch out 3 circles. Okay, if we change the scale, it's going to stretch out 6, but you know how it works. This is again n, and since it's even, then we know that the number of petals is going to be equal to 2 times 2, that is 4. So we know that we're going to have 4 leaves. Okay, so remember that sine is going to start right there. So we can grab the first one immediately. Okay, so now let me change the scales. So this is 1, this is 2 circles. So since this is 3, then I'm taking 1, 2, and 3. And I know that my first leaf is going to be like that. All right, without too much analysis. I know that it's going to be, this is a sketch. So I know that my first leaf is going to be right there. Okay, how are we going to find the next one? Well, we know that we need to stretch out the 4 leaves. So we need to take 360 divided by the 4 leaves. This is 90 degrees. So we know that it's going to stretch every 90 degrees. So if this is 0 plus 90, it's going to be right here. So 1 and 2 and 3. So this is 90 degrees, right? And 90 degrees plus 90 degrees will be 180. So 1, 2, and 3. So for 180, and again 270, because if you add 90, you get 270. So 1, 2, and 3, right? So if you try to grab this, so we're going to have a leaf like this, right? So we're going to get something pretty similar. If we're just sketching the graph, then we're going to get a rows pretty similar to that. So notice that the only changes that happens for cosine is that we're going to start here. The rest of the process is pretty much the same thing. Let's do one with an even number of leaves. Let's suppose that we want to graph 3 cosine of 5 theta. All right, we're going to graph that. Again, this is A and this is N. But since it's odd, then we know that the number of petals is going to be equal to that same number 5. Okay, so if this is 3, and let me change the scale again. This is 1 circle, this is 2 circle, this is 3, the third circle. So since A is equal to 3, we know that's going to be 1, 2, and 3. And my first petal is going to be like that. All right, like that. All right, but since we're going to space the leaves evenly and we have 5, then we're going to take 360, the whole loop. We're going to divide it by 5. 360 divided by 5, we already did it. And I think in the one of the first example, this is equal to 72 degrees. So we know that if this is 0 and I add 72 degrees, then my next leaf is going to be at 72 degrees. Remember that this is 30, then this is 60. We add 70, we have 15, we get 75. So it's going to be somewhere close to that metal. So if this is 60, then my 72 should be around here. Okay, it should be around there. This will be 72 degrees. Okay, we know that it's going to be spaced out evenly. So if we add another 72, we get 144 degrees. So it's going to be at 144. So this is 90 plus 30, you get 120 plus 130 is going to be 150. Right? So this is 150. This is 150. This is 135. So it's going to be again close to this value in the metal. So it's going to be around there. Okay. So this will be 144 degrees. So if we take 144, we add 72 more, we get 6, 11, 1, 216 degrees. So remember, this is 180, 30 more, 110, 50 more, 125. So it's going to be around here, right? So in this position, we're going to have 216 degrees, and we're going to have our fourth leaves. So if we add 72 more, we get 8, 8 and 2, 288. This is 270. This is 275. So a little bit further. Whoops. We're going to get something close to 288 degrees. All right, so let's finish graphing our leaves. So 1, 2, 3. Let's take 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay, so we can keep graphing. All right, let me do it properly. So we can keep graphing our petals just like this, right? That is our rows for the equation 3 cosine of 5 theta. So I don't think we need to keep going doing more examples. I think that you probably got how to graph them. So in the first comment, I'm going to pin a worksheet, a free worksheet that you can use to practice this, and it's going to include each of the equations is going to include this graph, so you can practice how to do it properly. Okay, so all right, see you in the next one.